Hello students, welcome to AdiChemistry online coaching. In this presentation, you will learn about the nitration of benzene and understand its mechanism step by step in a simple and clear way. I am Aditya Vardhan, the creator of AdiChemistry.com from Warangal. Let us get started right away. Here you can see the general representation of nitration reaction. Benzene reacts with a mixture of concentrated nitric acid and concentrated sulphuric acid at a temperature below 50 degrees Celsius to form nitrobenzene. In this reaction, a hydrogen atom on the benzene ring is replaced by a nitro group. This is the balanced chemical equation for the reaction. Benzene plus nitric acid gives nitrobenzene, and water in the presence of sulphuric acid as a catalyst. Let us take a closer look at the substitution process. During nitration, one hydrogen atom on the benzene ring is replaced by a nitro group. The removed hydrogen from benzene combines with the OH group from nitric acid to form a molecule of water. Now let us understand the mechanism of nitration. This reaction is a classic example of electrophilic aromatic substitution. There are three main steps in this mechanism. First one is generation of electrophile nitronium ion, and the second step is attack of electrophile on the benzene ring, and finally deprotonation. Let us now see how the electrophile is generated. When concentrated nitric acid reacts with concentrated sulphuric acid, it forms the nitronium ion NO2+. This nitronium ion is the actual electrophile in the nitration reaction and is responsible for attacking the benzene ring. Let us understand the steps involved in the generation of electrophile. In the presence of sulphuric acid, nitric acid acts as a base and accepts a proton. This is an example of a Lewis acid-base reaction where sulphuric acid donates a proton and nitric acid accepts it. The resulting protonated nitric acid is unstable and loses a molecule of water. This leads to the formation of nitronium ion NO2+, the key electrophile involved in the nitration of benzene. Now the nitronium ion attacks the benzene ring. One of the delocalized pi bonds in the ring temporarily breaks to form a new bond with the electrophile. This results in the formation of a positively charged cyclohexadienyl intermediate, also known as rhenium ion. At this stage, the aromaticity of the ring is temporarily lost. Finally, the intermediate rhenium ion loses a proton, which helps restore the aromatic character of the benzene ring. This completes the substitution and leads to the formation of nitrobenzene as the final product. The last proton then combines with the bisulfate ion, regenerating sulphuric acid, which acts as a catalyst in the reaction. Once again, the first step involves the generation of electrophile nitronium ion NO2+. Thus formed nitronium ion attacks benzene ring by giving an intermediate rhenium ion. In the last step, the intermediate rhenium ion loses a proton by giving the final product nitrobenzene and regenerating sulphuric acid. Now test your understanding. Nitration of benzene is option A, aromatic nucleophilic substitution reaction. Option B, aromatic free radical substitution reaction. Option C, aromatic electrophilic addition reaction. Option D, aromatic electrophilic substitution reaction. Your time starts now. And the correct option is D, aromatic electrophilic substitution reaction. Now the next question. Choose the correct statement. Option A, nitronium ion is an electrophile and is attracted towards positively charged entity. Option B, nitronium ion is a nucleophile and is attracted towards negatively charged entity. Option C, nitronium ion is an electrophile and is attracted towards negatively charged entity. Option D, all are incorrect. Your time starts now. The correct option is C. Nitronium ion is an electrophile and hence it is attracted towards negatively charged entity like benzene. That's all for now. Visit AdiChemistry.com for more information on this topic or search for AdiChemistry nitration of benzene. And don't forget to like, share, and subscribe. I also suggest you to visit brahmakumaris.com to learn Raj Yoga meditation freely and awaken your inner divine powers to lead a happy and successful life. All the best.